There's a problem with the bearing here at the rear wheel. It makes a knocking sound when the wheel is lifted up in the air and put back on the ground. When it's put back on the ground, something moves. You can see some motion where the disc rotor is interacting with those brake pads, and it also makes a knocking sound, just a single knocking sound. So let me try to duplicate this problem. So that's in the air, that's down. There is 40,000 kilometers on this bearing, and it needs to be replaced. This is how collapsed bearing or nearly collapsing bearing sounds like. This wasn't damaged in the removal process. This is how it looks like. It came out mangled like this when it was removed from the hub. So when the bearing collapses like this, then the axle shifts position, shifts up like so, and the wheel starts tilting to one side, and when the wheel tilts, then the brakes bind. At that point you may damage the brake pads, the brake calipers, maybe the lower end of the fitting that's on the fork. In short, this bearing collapse may be inconvenient. You may need a tow truck and a bunch of other parts. The rear section's mechanical stability is greatly affected by the condition of parts at three critical points. Firstly, the condition of bearings inside the rear wheel's hub. Secondly, the condition of bearings inside the swing arm pivot point right there. This is the point around which this whole swing arm or swinging arm pivots. It kind of goes up and then it comes back down and it mounts right there. And thirdly, the condition of bearings underneath the shock absorber lower mounting and linkage pivot points. Now on this particular make and model, the lower mounting point of the shock absorber is not visible. It's covered by fairing and exhaust components, but on some other makes and models this lower mounting point and or the existence of any linkages are plainly obvious out there to see. Either which way, wear at all of these three places combine together or add together to create mechanical instability. That's something you don't want, because it's detrimental to the rear section's cornering and safety. So it's possible to look at these three sources two ways. One, in isolation on a bench, taking measurements and making naked eye observations, as well as combined or linked together because they are mechanically linked and connected, and using the motorcycle's original geometry and weight. Let me show you what I have in mind. Let's start with the rear wheel. Get an axle stand or some kind of a stand and lift up the motorcycle's rear wheel off into the air like so. Now it's in gear. In this formation here, the wheel is in the air, the bearing is unloaded, but the swing arm isn't. The weight, motorcycle's weight or rear axle weight, is transferred from the swing arm to this deluxe wooden stick in this case, but the bearing is unloaded. If you shake the bearing sideways this way, as well as sideways this way, there shouldn't be any looseness to the bearing basically. But again, this is only good for rough condition assessment. One other potential source of this noise could be the swing arm pivot point. Extremely rare. This is the pivot point. This chunk of metal here is the swing arm here, and if you follow it all the way tapering there, that's the pivot point for it. So that could also be loose and wobbly. Next thing to do is take out the axle, pull it out, and check the bearings visually. It's fairly easy to access the bearings. There's one right at the top. The sprocket removes just like so. The whole thing just comes out from the hub assembly. So this is how the cleaned up hub looks like, and I've got the clean axle here placed inside. Now there should be a clearance between the axle and the inner race of the bearing, some, but not a whole lot. So when the axle goes in, there it fits like so. Yeah, I think that's just too much for clearance between the axle and the bearing. Yeah, that's not sitting too well with me. So I'll show you how the bearings come out and what you need for it. This side I have already removed the bearing and cleaned up the part of the hub where the bearing goes. So that's how it looks like when it's done, and that's how it looks like, of course, when you start. So what you need is a piece of wooden block on its edge that you can put down like so on the ground, just so you transfer the load of banging. So the wheel is not resting on its rim. It's not, as much as possible, it's not resting on the edges of the brake rotor. It's resting with the blocks supporting something like this, as close as possible or reasonable to the center of the hub. Yes, it's gonna be rocking on these bolt heads a bit, so be it. A little bit of rocking is okay. It's not gonna rock a whole lot though, because it's gonna be, the bearing is gonna be beaten out of it. Let me take you off the tripod here for a sec. What you see on the inside of the hub, so this is now the clean side, or the side from which the hub has been, or what the bearing has been removed from the hub, and this is what you see. You can see the bearing. This is my pointer now. Maybe I can put my hand in here. Yeah, you can see the edge of the bearing there through the hub. So you need to get a piece of steel, suitable piece of whatever, chunk of steel. I don't know, here is a nail bar. I'll explain the nail bar in a sec, and a big enough hammer. And the name of the game is tap the bearing out so it's coming out evenly and uniformly, not sideways, enlarging the hub, deforming the hub, destroying the hub. No, the bearing needs to advance one tap at a time, one side at a time, evenly, neatly. So hit it, one side, opposite side, third quadrant, fourth quadrant, and then keep going, and something like that in the same pattern. But you also have to check it and modify your pattern a little bit as needed. So start anywhere, and opposite side 180 over. That didn't sound like it's advancing much. That's more like it. Needs a little bigger bang. Yeah. Turn 90 degrees. Turn another 90. Okay. Completed one circle. Check progress. And I don't have a whole lot of visual reference here on this side, because this seal is in front of the bearing, but I can see the distance to the black seal, and I can look around it all around, something like that. Make sure it's advancing evenly everywhere. Nice. The seal just dropped to the ground. Oops. There. That's fine. And let's see how the bearing is advancing. Oh yeah, I can see it in any angle that it's advancing nicely and evenly, because it's flush to the edge of the hub everywhere evenly. It's coming still evenly. Nice, nice, nice. See, it's not rocket science, but it just needs a little TLC. It doesn't need a 5-ton press or any kind of press to put the bearing in either. Just needs basic hand tools, such as hammer. The bearings are NTN brand. It's a Japanese bearing. The size is a universal size. 6205 is the size. LU basically just describes in NTN terminology that this is sealed on both sides. And this is how the cleaned up bearings look like. So this was on the left side, we're going forward in that direction, and this was next to the brake, the rusty air. So happy spinning is not a cause for acceptance and celebration. This is trash, not just rusty, it actually runs badly. Okay, runs with too much clearance and too much play. So when the axle was through both of these and I was playing with the axle, yeah, this is way too much. So let's take a look at how the components go back together. First off, you need new bearings in a sealed box like so, and inside the sealed box the new bearing should be in a plastic, also sealed. There should be some assembly lubricant on the bearing, just like so. And oh yeah, the NTN brand is gonna be replaced by this SKF top of the line bearing. This is gonna be the replacement. And before I put this one in, the bearing is gonna go into the freezer for half an hour because it's easier fit into the hub there. This is a standard 6205 bearing. There is also an inch based variant available. Even though this is a metric bearing designation, there is an inch based variant on it. Don't overthink it. This is a metric bike with a metric wheel, even though it's 17-inch diameter wheel. Nevertheless, it's made to work with this standard 6205 bearing. Doesn't matter which side you start with, which side you put in first. Put one of the bearings in and then put the spacer bar in, of course, from the opposite side. Don't forget this spacer. This spacer is running from the inner ring, the inner race of one bearing like so, to the inner race of the other bearing. When you clean this up, do resist the temptation to make it shorter or whatever. Don't be cute on this and don't overthink it. Its length is critical. I've also cleaned off the corrosion products that were kind of fused to the sidewall of the hub here, so that the bearing can go in just like so. Lubricate the sidewalls here a little bit, not the tires sidewall, just the hubs recess there, just lightly. This is gonna help in placing the bearing and make sure that the bearing is advancing evenly, as well as keeping further corrosion to minimum. What you need is a piece of pipe that's almost as big as the bearing itself, but just a little smaller, so that it doesn't get stuck in the hub's recess when this is driving the bearing. And the life here is fairly straightforward. Line up the two things, tap on the pipe. There, have a look at it from this angle, something like that. I'm actually spending, this one is set within 10 minutes, but I'm actually spending more time looking than actually tapping, because it's gonna go into place, it's gonna sink into place with, say, 20 taps, but I'm looking more than tapping. What you do not want to do is advance this bearing skewed or unevenly, because if it advances unevenly, that means that it's gonna make the hole in the hub larger. That's better. Yeah, nice and flush. That's why I'm looking, that it's advancing evenly everywhere. So this is a good reference point there, that it's flush with the surface. Oops, at the moment. Seal that got removed from this side and got cleaned is going to be recycled and placed on top of it, also set in place carefully with enough grease between the two of them to keep out moisture again, because this is the side that gets more rusting. Once this place is lubricated, this black seal just goes in literally like so. Okay, that's it. You see all that grease there on the inside there, that's been placed there. So when I put the spacer in. The bearing's inner part is also somewhat protected with that grease. That's how it looks like. Now on this side, because the bearing is sticking out so much, you can just go like so. Only the outside, don't hit the inside. I'm angling the face of the hammer. Yeah, I have nice and flush and level with the surface. That's good. So you see it's pretty fast. Okay, fairly fast. Does not need expensive tools or exotic tools or a bench or a pressing hydraulic whatever. This is not a car. This is motorcycle where bearings and hubs and everything is as light as possible. Assembly wise, this is gonna go back into place. It's gonna go over it just like so. There, just like that. Of course it needs these rubber spacers. There is a third bearing inside here, but at the moment there you can see the there you can see the rolling elements, the bearing balls there with this light. Okay, for now I'm just gonna leave it alone. Now I'm gonna push the axle through, and this is gonna line up the spacer bar perfectly. So far so good. It's easy. Okay, it got greasy now because of the grease, because this wider shoulder here is gonna help line up the spacer bar with a little bit of, I'm just pushing it in place like so. There. It's perfectly aligned now. Let's see what this does in terms of play sideways. Nothing. No wobble. Really solid. I like it. And of course, for this assembly to be this quiet, you have to wait until the frozen bearing's temperature rises and evens out or equals out with the temperature of the axle and the hub and everything else. So that's how it should look like. The axles can also be worn, and there's always going to be a clearance between the axle and the inner ring on the bearing. Now the wear on the axle isn't much, a thousandth of an inch or whatever. If you can feel it with your hand, it's too much. This is not really operating temperature, so when the bearings expand and the axle expands while it's rotating, and that's generating some heat, whatever, so don't worry about too much. Tiny little gap. Okay, I'm gonna put it together. Fairly straightforward. This gets pressed in place on this side of the wheel, just pressed in place, and tighten the bolts. The wheel has been mounted back, the chain is tensioned correctly, the wheel nut is tightened, there is the cotter pin through it, there is still no brake on it, so we can compare the before and after without the brake in the same setup. Everything has been also meticulously cleaned, especially both faces of the brake rotor, as well as a little cosmetics on the hub and the spokes and the rim.